Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Welcome back. We're continuing a video series on right triangle trigonometry, at least an introduction to it. My name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. And prior to this video, you should have watched all my videos in this right triangle trig series, which is a few. One is on triangles, one's on special triangles in trigonometry, another one's on trigonometric functions from the right triangle perspective. And the last one we did was evaluating trigonometric functions for the acute special angles. And now we're going to take an aside here and talk about cofunctions and cofunction identities. Now, I alluded to this in the previous video, but here we're going to label it completely. And we're not going to prove it now because we need an identity to prove these, but it is presentable at this time. So here's the theorem. The sine of pi over 2 minus theta is the same thing as a cosine. Cosine of pi over 2 minus theta is the same thing as a sine. Essentially, if you read through this, all of these are saying the same thing. A function is equivalent to its cofunction, just shifted by pi over 2. Another way of saying that is that a trig function of an angle is always equal to the cofunction of the complement of the angle. And that is going to be an identity that you sometimes use. It's not actually used all the time, but it's something you're going to notice, so we might as well just talk about it. As I said, we showed it in the previous video, specifically when we found the sine of 60 degrees to be root 3 over 2, and then the cosine of 30 degrees to be root 3 over 2. That's the cofunction identity in action, that the sine of 60 degrees is the cosine of the complement of 60 degrees. And so what we'll do here is we'll just show how to use the cofunction identities. And again, I just want to reiterate that these are good identities to know. You'll see them in use as far as the results of them. You'll see that quite often. Do people use them a lot? I don't, but some people might. And also notice that I have this written in radians. I did that on purpose because I think that it's important for you to get used to radian measure, but pi over 2 is 90 degrees. So the first example we're going to do here is just to verify the cotangent identity, or sorry, the cofunction identity. So the cofunction identity that's being tested here is the tangent of pi over 3 the same as the cotangent of pi over 6? Let's go ahead and verify. And the way you would do that is just draw out a right triangle that is a pi over 6, pi over 3 right angle. Remember, the smallest side gets the 1, so 1, 2, root 3. And let's just verify the tangent of pi over 3. I'll go to the pi over 3 angle. Right here, tangent's opposite over adjacent, so it's root 3 over 1. I'll write that in. And then I'll look at the cotangent of pi over 6, which is just the complement of pi over 3. The cotangent is adjacent over opposite. Adjacent to pi over 6 is root 3, opposite's 1, so it's root 3 over 1, which is exactly what we got with the tangent of pi over 3. So it is true that the tangent of pi over 3 is the same as a cotangent of pi over 6. It's because, honestly, the reason why the cofunction, sorry, I keep saying cotangent, but the reason why the cofunction identity works is because you're finding a trig function for this guy right here, right? And the trig function you're finding, let's just say it's, I don't care, it doesn't really matter, but let's just pretend it's adjacent over hypotenuse. That would be the cosine, right? Adjacent over hypotenuse. Well, what's the cofunction to the cosine? The cofunction to the cosine is the sine. Oh, I didn't make a big deal about that. Actually, I should have mentioned why they're called cofunctions. It's because the word co that gets attached to them. So the cofunction for the sine is the cosine. The cofunction for the tangent is the cotangent. The cofunction for the secant is the cosecant. So it turns out, if you highlight in color here the cofunctions are sine and cosine, they get grouped together. And tangent and cotangent, they're cofunctions. And then finally, secant and cosecant, those two are cofunctions. All right, going back to what I was trying to say before I reminded myself that I didn't say something. If you take a look at this triangle and you said, oh, I want adjacent over hypotenuse here, well, that's the cosine. So we're looking at the cosine of pi over 3, which is 1 over 2. The cofunction to the cosine, it's sine. So the sine of the remaining angle, non-right angle, so in other words, the complement of pi over 3, the sine is opposite over hypotenuse. And that is also 1/2. So this is 1/2 is also equal to the sine of pi over 6, which is the complement of pi over 3. So it turns out it's because you're looking at the other angle within that triangle, and the cofunction kind of points at the same parts. So your function that you're originally considering, whether it's sine or cosine, doesn't really matter, its cofunction will point at the same parts if you're looking at the complementary angle. You can try that out all day long, it is true, but let's go ahead and move on to another example. Well, here's an interesting problem. We're given an angle, cosine, the angle is pi over 8, and a second angle, 3 pi over 8, and both of these are not special angles. We do not have triangles to represent these, and so we're kind of stuck. You cannot invent a triangle for this right now, at least. Our only special angles that we have are pi over 6, pi over 4, and really pi over 3. Those are the 3 special angles that we have, and these are none of those. So what are we going to do? Well, if you didn't know the cofunction identities, you would not be able to do anything, actually. You'd be stuck. But because we have the cofunction identities, we could say that the cosine of pi over 8, which is what we want to find, should be the same as its cofunction, which is sine, evaluated at the complement of pi over 8. The complement of pi over 8 is pi over 2 minus pi over 8. Oops, that's supposed to be pi over 8 right there. Sorry about that. And if you reduce or simplify that fraction, that's sine of 4 pi over 8 minus pi over 8, which is the same thing as sine of 3 pi over 8. And all of a sudden, you know what the cosine of pi over 8 is. It is equal to the fraction where the numerator is the square root of 2 plus the square root of 2, all over 2. So this is a really good reason. This specific style of example is a great reason for you to really get to know your cofunction identities. Even if your instructor doesn't make a big deal about them, I think they're very important. They can be incredibly helpful. It's not that I use them a lot, but when I have to use them, I mean, there's no other way you could do a problem, really. So it's a good idea to really understand this and know that the sine and the cosine are cofunctions to each other. Tangent and cotangent are cofunctions to each other, and the secant and the cosecant are cofunctions to each other. So if you have a value for one at an angle, then you have the value for the other at the complement of the angle.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together here until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.